Ladies and gentlemen, the recipients of the 2003 IEEE Medals and Awards, escorted by the 2003 IEEE President and President-elect.
Good evening, everybody, and thank you for the warm reception. Welcome to the 2003 IEEE Honor Ceremony. Sharing the podium with me tonight is our President-elect, Arthur Winston.
Thank you, Mike. I'm delighted to be here to share this occasion with you.
Thank you, Arthur. Ladies and gentlemen, welcome to Nashville and Opryland. Our gracious host this evening is the IEEE Central Tennessee Section. It boasts more than 800 members and has a very active student branch at Tennessee Tech, Vanderbilt, and Tennessee State Universities. The section recently co-founded the Tennessee Engineering Center here in Nashville. The center, which opened last July, is a $1.8 million facility built into the Adventure Science Center. The section raised over $75,000 for the project and now uses the center for all its meetings. I was honored to be able to tour this facility, and it was indeed impressive. You have made a contribution that sets an example for other sections. Thanks go to you, the members of the IEEE Central Tennessee Section, for your inspired work. This is an amazing time in technology. The pace of change has reached the dizzying mark, having long passed breathtaking and astonishing. Cell phones, laptop computers, digital cameras, MP3 players, PDAs are an essential part of our lives. And they keep getting better, easier to use, easier to carry, and above all, faster. 52 kilohertz, broadband, third-generation wireless broadband. Much of this development has been driven by advances in solid-state devices and circuits. In the last 50 years, since the invention of the transistor, no field has changed faster. To put it into perspective, there are now as many transistors shipped as there are grains of sand in the world, almost 10 to the 19th. In 1968, a transistor cost $1. Now $1 buys almost 10 million transistors. While change progresses in one direction, it also races in all directions at once. Wireless applications, biomedicine, and nanotechnology, for example. New developments seem to appear almost as fast as we can think of them. Indeed, it is as if change now happens at the speed of thought. The IEEE embraces technology influenced by many of those we honor here tonight. The technologies help us to reshape the way we communicate and bring information to our members. But for the IEEE, communication and information sharing are not enough. As we move into the 21st century, the IEEE is addressing three strategic issues. First, we must make the IEEE the place to go to obtain and publish information. We must be the electronic portal to the engineering world, a major information hub where the best and brightest go first to publish and be informed. Next, we must invigorate volunteerism because it is the lifeblood of our organization. We want IEEE members to be excited about the IEEE and wish to be volunteers. Volunteerism benefits members not only through the experiences they gain, but also through the contacts that they make. Finally, we must reach out to industry leaders. They employ IEEE members and our customers for our intellectual property and standards. We need to ensure that industry continues to see value in the IEEE and supports their employees' participation as members and volunteers. We must rise to meet the challenge inherent in our profession and the speed of change. We do this so the IEEE can connect a sophomore at MIT with a germ of an idea to the Nick Holonyaks of the world and light the torches of the next technological revolution. So let us begin showering much-deserved accolades on the extraordinary human beings gathered here tonight. They are among the great minds that springboard us from possibility into reality, and drive change at the speed of thought.
Thank you, Mike. Before we present the IEEE medals and awards, we will begin with the eminent member recognition from Eta Kappa Nu.
With us tonight to assist in this presentation is Eta Kappa Nu Executive Director Ronald Spanky and Eric Hurst, IEEE Director Emeritus and National Vice President of Eta Kappa Nu, who in fact will be its president on July 1.
Thank you, Mike. Thank you, Art. Eta Kappa Nu is the U.S. National Electrical and Computer Engineering Honor Society. The society recognizes individuals of exemplary character who have made contributions to the field in both their collegiate and their professional life. In 1950, Eta Kappa Nu established its highest membership rank, Eminent Member. It is conferred upon those select few whose technical contributions have significantly benefited humankind. Only 99 individuals have been elected and inducted to hold the Eminent Member designation. Today, another very special IEEE member will join this prestigious list. The recipient of the 2003 Eta Kappa Nu Eminent Member recognition is Dr. Donald R. Scifres, Chairman of SDL Ventures in San Jose, California. He receives this selection as Eminent Member for notable accomplishments as engineer and entrepreneur and for his inspirational contributions to the welfare of the profession and to society at large. IEEE fellow Dr. Donald R. Scifres is recognized for pioneering work on the first distributed feedback semiconductor injection laser and for the vertical cavity surface emitting laser and for the benefits these technologies have brought to humankind. Dr. Scifres, will you please join us on stage? With us tonight is Eta Kappa Nu National Vice President Eric Hertz, and Eric Hertz will perform the official Eminent Member induction. Eric?
Thank you, Ron. Dr. Donald Scifres, by the power vested in me as National Vice President of the Eta Kappa Nu Association, I hereby induct you as the new Eminent Member of Eta Kappa Nu. Well deserved. Let's say a few words. Mike will hold your certificate.
I can hold this for you.
Thank you. It's a tremendous honor to be named to this award. When I look back at the list of prior awardees, I'm really in awe of that nomination and election. In order to get here, I really would like to thank a number of people who over the years have contributed so greatly to this, to my receiving such an award. That includes my family, some of whom are here, for their love and patience through the years. And I'd especially like to note three people who are in the audience today that really had a great deal to do with my career and with the formation of the company that we formed back in 1983. Those three people are Dr. Bill Spencer, who was responsible for helping put together the company, SDL. He was the head of Xerox Palo Alto Research Center, and he was just regaling me tonight with the thought that there was a teeter-totter balance of whether this would get put together or not, which I didn't even know about due to questions about laser eye safety. So that's a new one that I hadn't known before tonight. Dr. Russ Dupuy, who developed a technology, metal organic chemical vapor deposition, and got it to a stage where we could manufacture that technology and really put it in use across the world. And also Professor Nick Holonyak, our Medal of Honor winner tonight, who really inspired me from the beginning when I was in graduate student, as a student of Nick, not only to understand how technology works, how lasers work, how semiconductor materials work, but also how to get how to really have a small group that can achieve great things. You simply take a few people, a lot of energy, a lot of hard work, and have a lot of fun at it, which is what happened. And Nick really was the inspiration for that. So I wanted to thank those three especially. And finally, to make a successful company, we started out with a product that no one knew how to use. And our customers, many of whom are in the audience tonight, figured out that you could do everything from laser eye surgery to welding automobile parts with these products that we eventually made. Now, back in 20 years ago, no one could even figure out how to do anything with them. So I congratulate those people in the audience that have really helped make this field a complete success over time. Thank you very much.
Congratulations, Don. We look forward to bringing you back on stage later this evening. Each year, the IEEE Board of Directors elects a limited number of senior members to the grade of IEEE Fellow. The grade of IEEE Fellow recognizes unique distinction in the profession and is conferred upon an individual with an extraordinary record of accomplishments in any of the IEEE's fields of interest. The IEEE Fellows are an elite assembly. The number elected in any given year may not exceed 1/10 of 1% of the voting membership of the IEEE. This year, 260 senior members have been elevated to IEEE Fellow. They're being honored at numerous IEEE conferences and meetings throughout the year.
The 2003 IEEE Fellows and their citations are listed alphabetically in the last 5 pages of your awards booklet. Tonight, 2 of them, Ronald C. Arkin and Mubarak Ali Shah, have joined us here. Ron and Mubarak, would you please stand up so we can all congratulate you? Also in our audience are IEEE Fellows who have been elected in previous years. I would now like to ask them to stand as well. Congratulations on your accomplishments.
Now I would like to invite Dr. Litsa Michele-Zanaku, Chair of the IEEE Awards Board, to explain how the awards process works. Litsa?
Thank you, Arthur, and good evening, ladies and gentlemen. The IEEE Awards Board administers 7 categories of awards that are bestowed by the IEEE Board of Directors. These include honorary memberships, corporate recognitions, service awards, prize papers, scholarships, technical field awards, and IEEE medals, including the IEEE Medal of Honor, which is our highest award. The awards typically consist of gold and/or bronze medals, certificates, and honoraria. Some are funded by the IEEE Foundation or IEEE organizational units. Others are funded by industry or individuals. A complete list of this year's sponsors is found on page 2 of your program booklet. For each award, an independent selection committee conducts a rigorous evaluation of all nominations. The committee submits its recommendations to the awards board for endorsement, with final approval granted by the IEEE Board of Directors. I would like to take this opportunity to encourage all of you to nominate worthy candidates for IEEE awards. Enclosed in your program booklet is a potential nominee form that is used to stimulate nominations for IEEE medals and awards. By completing and submitting this form, you bring a deserving individual one step closer to being recognized for his or her extraordinary accomplishments. On behalf of the IEEE Awards Board and its committees, I would like to thank everyone who participated in this year's selection process and tell you how proud we are to acknowledge the achievements of the 2003 recipients. Thank you.
Thank you, Litsa. We begin this evening with the presentation of the IEEE corporate recognitions. The first is the IEEE Ernst Weber Engineering Leadership Recognition. It is granted for exceptional managerial leadership in fields that are of interest to the IEEE. The award honors Ernst Weber, the first IEEE president.
The 2003 IEEE Ernst Weber Engineering Leadership Recognition goes to Dr. William J. Spencer of Sematech for engineering leadership in raising performance in semiconductor manufacturing and fostering cooperative work towards international standards.
Dr. William Spencer's career began at Bell Labs, where he led a group that built circuits for the first active communications satellite. Later, at Sandia National Labs, he headed the development of a sophisticated semiconductor facility. He also championed a collaborative effort with the University of New Mexico to develop a pioneering implantable electronic drug delivery system. In 1990, he stepped into Robert Noyce's shoes at Sematech, where he is now Chairman Emeritus.
In the late 1980s, the U.S. semiconductor industry was lying on the floor of the world's marketplace, struggling to breathe as it lost more and more global market share. With lights flashing and sirens blazing, Dr. William Spencer came to the rescue. At Sematech, he worked quickly to drive manufacturing improvements and supply chain efficiencies. He developed unified industry specifications for raw materials, which cut costs and accelerated growth. Most importantly, Dr. Spencer redefined the relationship between U.S. chip makers and their suppliers. No longer adversaries, suppliers and customers developed standards, specifications, and other criteria together, and the industry was reinvigorated. It is an honor to present Dr. William J. Spencer with the 2003 IEEE Ernst Weber Engineering Leadership Recognition.
Thank you very much for those kind words. I'm afraid some of the sirens when I went to Austin were wailing for different reasons, but I'm not sure that any of us at Sematech would take credit for turning the semiconductor industry around, but it was a great time to be in the semiconductor industry because it did turn around. I'm honored to be here tonight. I appreciate the award and the honor. Whenever these things occur, having been on many of the award committees here in the IEEE and other organizations, I know the hard work that goes into preparing a nomination and getting it through the awards board. Tonight, I'm honored to have one of those people who thought I was worth that effort, and he's here from Berkeley. Dave Hodges has been a longtime friend and associate. We started in Bell Labs together a long time ago and have fought a number of battles. Dave, I appreciate very much what you did, and I hope you'll pass those thanks on to people who worked with you. Any time that you enjoy any success in leadership, it has to be because you have an outstanding team that you work with. I've been fortunate in several decades of work to have worked with some really outstanding people. Perhaps the one, though, that has influenced whatever success I've had and the organizations I've been in is also here tonight. And while I've been having fun, as Don described, they were able to keep the family together and do the important things. And without the support of my wife, and I won't say how many years, dear, and our daughter, who are both here tonight, none of these things would have been possible. So
Thank you for all of that support, and I'm looking forward to another 50 years.
The IEEE honors exemplary contributions by an industrial entity or a governmental or academic organization with the IEEE corporate innovation recognitions. The contributions may be an innovative product, system, or concept that results in a major advancement of electrotechnology.
This year, the IEEE has selected 2 corporations to receive this award, the Titan Corporation and the Xerox Corporation. We'll start with the Titan Corporation. Titan is being honored for leadership in developing electron beam technology and revolutionizing the field of medical sterilization, food safety, and biosecurity of the male.
Dr. Gene W. Ray founded the San Diego-based Titan Corporation in 1981. Contracted by the U.S. Department of Defense, Titan developed direct-energy, high-powered electron beams for the Star Wars weapons system. Later, Titan applied its SureBeam technology to the fields of medical sterilization and food pasteurization, revolutionizing the way pathogens are destroyed on medical devices and in ground beef products.
Titan SureBeam, the first reliable, high-speed industrial irradiation system, makes everything from hamburgers to home dialysis safer. Using an electron beam powered by a linear accelerator, the system scans millions of pounds of meat and fruit every month. More than 4,000 U.S. supermarkets use the technology to protect consumers from deadly bacteria and environmentally harmful pests. This technology became a matter of U.S. national security during the bioterrorism attacks of 2001. SureBeam proved so effective in killing anthrax spores that the U.S. Postal Service purchased 8 systems and changed the way it processes mail. On behalf of the IEEE, I am pleased to present the Titan Corporation with the 2003 IEEE Corporate Innovation Recognition. Here to accept the award is Titan's founder, Dr. Gene W. Ray.
Thank you very much for this great honor. I accept it on behalf of the some 11,000 scientists and engineers at the Titan Corporation who are very innovative. We started this technology back in the early to mid 80s working on Star Wars. And then, thank God, peace broke out and Star Wars disappeared and we had a solution and no problem. So our innovative engineers really did find some solutions for the solution, found some problems for the solution that we had that really did solve a national public health problem, and indeed a year and a half ago did show that it was very effective in sanitizing the mail, both for the White House and for Congress. So hopefully it will continue, this technology will continue through the years to save lives and make our food healthier. Again, we are very honored at Titan for this award. Thank you very much.
The next recipient of the IEEE Corporate Innovation Recognition is Xerox Corporation for its Docutech product line, which unified digital, electronics, computing, and communications with xerography to create the print-on-demand industry.
Xerox was founded in 1906 in Rochester, New York as the Haloid Corporation. It changed its name in 1961 upon commercializing the world's first photocopier. When Xerox introduced Docutech in 1990, it did more than introduce an innovative new product. It created a new industry, print on demand.
The Docutech system is the Elvis Presley of printing technology. It exploded on the scene, and no one had ever seen anything like it. By merging digital electronics, computing, communications, and xerographic technologies, Xerox made it possible to print documents when, where, and in the exact quantity required. Docutech not only made printing faster and easier, it drastically improved print quality allowing for a more dynamic page. Today, companies can send complex documents with color, illustrations, hypertext, and charts anywhere in the world to be printed on demand. With print on demand, Xerox created an entirely new market segment and spurred a sweeping change in the industry. By 2001, numerous industry competitors were developing similar products, and the market was estimated to be worth $26 billion. I am pleased to present the Xerox Corporation with a 2003 IEEE Corporate Innovation Recognition. Accepting for Xerox is Dr. Hervé Gallaire.
Thank you, Art and Mike. It is a great honor for me to be here accepting this prestigious award on behalf of all the people of Xerox, the people who had the vision to create the Docutech product family, and all the people who worked hard to make it a success. Docutech combined pre-press work, digital printing, and finishing capabilities thanks to many innovations, including massive concurrency, high-speed image capture, processing and networking, an icon-based graphical user interface, and leading-edge xerography. Docutech was as revolutionary to reprographics as the PC to the computer industry. It spawned an industry which in 2002 was $30 billion as retail value. The print-on-demand industry will continue to grow, today printing 400 billion pages a year. Docutech was also the forerunner of the digital transition from copiers to multifunction devices across the world. A world that continues to move swiftly, thanks in particular to the innovation efforts of communities like the IEEE, which continuously create opportunities for competitive advantage. In our business, we anticipate that the world will look very different in the future. New advances in every domain, from MEMS to programming and user interface, just to name a few, will fundamentally change our systems. Just as in the Docutech days, it is fun to be an engineer today. Thus, I'm particularly pleased to be here tonight with two distinguished Xerox alumni, Bill Spencer and Don Scifres, who also have been recognized for their outstanding contribution to the profession. The Xerox management is delighted that the IEEE views Xerox as an innovative company, along with the many great engineers recognized by this world-leading institute. On behalf of Anne Mulcahy, our CEO, and all the people of Xerox, I thank you for this great honor. We value the respect and confidence of the IEEE community, and we will work hard to continue to earn it. Thank you very much.
The IEEE honorary membership recognizes individuals who are not members of the IEEE, but who have rendered meritorious service to humanity in IEEE's designated fields of interest. This grade of membership is awarded for life.
This year, we present two IEEE honorary memberships. The first goes to Jorma Ollila, Chairman of the Board and CEO of Nokia Group, Finland, for contributions to launching mobile communications, a major global industry that has fundamentally changed the way people communicate.
After just 1 year at London Citibank, Dr. Jorma Ollila became Senior Vice President of Finance and a member of the Group Executive Board. In 1990, he was appointed President of the Mobile Phone Division, and in 1992, President and CEO of the company. Business Week named him one of the top 25 executives in 1999. Industry Week named him CEO of the Year in 2000, and Time Magazine named him one of the 25 most influential CEOs of 2001.
Dr. Ollila's career doesn't resemble the corporate ladder. It is more like a corporate high-speed elevator. In retrospect, the reasons for his rapid career ascent are clear. He has transformed Nokia from a national conglomerate into a global leader in mobile communications, not to mention one of the best managed and most innovative high-tech companies in the world. One colleague puts it concisely, Jorma has uncommon leadership ability. It seems Nokia's slogan, connecting people, epitomizes both what the company does best and the talents its leaders possesses. Unfortunately, Dr. Olila is unable to be here to accept this honorary membership, but he's with us in spirit and thoughtfully provided a videotaped statement. Let us take a look.
I would like to extend my most sincere thanks and gratitude to the Institute of Electrical and Electronics Engineers on being elected an honorary member. It's a privilege to be associated with so many distinguished recipients of this award in the past, and I'm extremely pleased to receive such acknowledgement. The IEEE brings together like-minded people with shared goals. It connects people and organizations worldwide that have a real passion for innovation. It supports the flow of new ideas and helps expand knowledge. Today, we are living in a global village in which information and communications technology plays an ever-increasing role. What we do with technology and how we use it is the fundamental economic and social challenge of our time. It will determine our success as a society for years to come. Advancements in new technologies, especially mobile communications and the internet, now span every country and culture of the world, providing both developing and developed nations unparalleled opportunities. Through improving access to information, stimulating new business and increased productivity, communications technologies remain a vital engine of growth for the world economy and a catalyst for all other industries. And as we see all disciplines of technology becoming ever more intertwined, we also see achievements in one area lead to achievements in other areas. It was John F. Kennedy who once said, "United, there is little we cannot do in a host of cooperative ventures." I would like to echo those words, as true cooperation between all parts of society, public and private, will be one of the cornerstones in developing technologies for the advancement of society. The mobile communications industry has already shown that over 1 billion individuals can communicate and transcend traditional boundaries of geography, and that number continues to grow. The role it plays is truly fundamental in transforming the way people live and conduct their lives. Once again, I would like to express my pleasure at being recognized by the IEEE with such a special and significant award. Thank you very much.
The second IEEE honorary membership goes to Dr. Tadashi Sasaki, President and CEO of the International Center for Materials Research in Kanagawa, Japan, for leadership of the commercialization of liquid crystal displays and the development of the pocket calculator.
Before founding the International Center for Materials Research, Dr. Tadashi Sasaki spent 30 years at the Sharp Corporation, 25 of them as corporate executive director. Through the use of liquid crystal display and miniaturization technologies, he and his team developed the earliest commercially available LCDs and pocket calculators.
"30 years ago, Dr. Sasaki could not accept the fact that his calculator would not slip nicely into his pocket. Fortunately, he had a plan. He developed the now ubiquitous liquid crystal display and miniaturized the device. Under his guidance, Sharp began mass production of the world's first LCD calculators, paving the way for many other tiny display applications such as digital watches, automobile navigation systems, and personal digital assistants. The LCD is now an $85 billion industry. As fate would have it, as this technology was good for large screen displays as well as it was for thin calculators. The LCD flat panel screen orbit navigation system that Dr. Rocket Sasaki created for the space shuttle was a precursor to the wall-mounted flat screen TVs enchanting today's consumers. Now in his 80s, this industry pioneer is still hard at work. As chairman and CEO of the International Center for Materials Research Incorporated, he researches and develops new industrial materials using nanotechnology. Ladies and gentlemen, please welcome 2003 IEEE honorary member, Dr. Tadashi Sasaki.
My Honorable President, Dr. Adler, ladies and gentlemen, it would be the greatest honor and commemoration in my life that IEEE has awarded me 2003 honorable membership. I would like to express my hearty thanks and sincere gratitude to everybody attending here and for all of my associates who have given me continuous stimulation for my concentration on research of electric and electronic engineering, for instance, solar energy system, semiconductor, pocket calculator, and display system. My effort will be continued furthermore to contribute for scientific and industrial development of information engineering. Your strong support and encouragement in future will be also highly appreciated. Finally, I would like to ask your understanding that my honor today should be shared with my wife, who has encouraged and helped me always dedicatedly. I would enjoy my happiness with my wife, expressing my heartiest acknowledgement of her contribution over half century. Thank you very much indeed for your kind attention.
We now turn to the IEEE Service Awards. The IEEE Richard M. Emberson Award was established in 1986 to recognize distinguished service to the development, viability, advancement, and pursuit of the technical objectives of the IEEE. Sponsored by the IEEE Technical Activities Board, it is named in honor of Dr. Richard M. Emberson, a highly revered former executive director and general manager of the IEEE.
The recipient of the 2003 IEEE Richard M. Emberson Award is Dr. W. Kenneth Dawson. He receives the award for leadership in influencing and motivating actions leading to significant improvements in the Institute's information technology system and in the interaction between technical and publication activities.
Dr. W. Kenneth Dawson has held many IEEE positions, including Publications Activities Board Vice President, IEEE Nuclear and Plasma Sciences Society President, and Editor-in-Chief of that society's transactions and newsletter. He also served as Division 4 Director, representing electromagnetics and radiation on the Board of Directors. In Canada, this IEEE Fellow founded the Nuclear Research Center, now the Center for Subatomic Research. Dr. Dawson is Professor Emeritus of the Physics Department at the University of Alberta.
Ken Dawson has dedicated much of his personal time to ensuring the success and technological evolution of the IEEE. He served diligently on our Information Systems Advisory Committee, where his expertise was crucial to the delivery of a truly effective IT system. During the mid-1990s, Ken was a key member of the IEEE Organizational Improvement Initiative, restructuring the bylaws to give more autonomy to the major boards and to establish the IEEE Standards Association and IEEE USA. His service to the Bylaws Task Force also included rewriting the IEEE Publication Activities Board bylaws, which realigned that board's relationship with the Technical Activities Board. Ken has played a key role in transforming IEEE into the well-oiled machine it is today. Ladies and gentlemen, please join me in congratulating the 2003 IEEE Richard M. Emberson Award recipient, Dr. W. Kenneth Dawson.
Thank you, Mike. Thank you, Art. The first thing to point out is that a single person doesn't win an award like this. As Art and Mike, both Arthur and Mike both know, you have to have a lot of help from other volunteers and staff in order to get things done at IEEE. You can't do them by yourself. And so there are a lot of people, and if I tried to start to name them, I'm sure I would leave some out. So what I much prefer to do is to just talk about three. One is a volunteer who has played a significant role in my becoming a member of the IEEE. Another is a staff person who has played a significant role in my getting work done within IEEE. And the third, of course, is my significant other. Now, the volunteer is Lou Costrell. Maybe certainly you in Standards know Lou. And many years ago, I was tasked with trying to put together a control system for the Triumph Accelerator and was told that Lou Costrell was the man to talk to about a certain standard that could be useful in the system. Well, I phoned Lou, and 2 weeks later I found myself meeting with him in New York, discussing with the Europeans as to how best to try and proceed to do this. And so Lou didn't know what he was getting into when he invited me, and I didn't know what I was getting into when I accepted his invitation. Lou, by the way, is retired many, many years ago from the National Bureau of Standards, which I believe is now called the National Institute of Science and Technology, which Lou reluctantly admits to that being the title. Clearly Lou, for me, is somebody who is worthwhile emulating, and it's something I'm still working on. The staff person choice was a much more difficult one, because I've worked closely with TAB, I've worked closely with publications, I've worked closely with many things, and if I try and pick somebody from TAB, then I will be neglecting some other people. And so I decided that maybe it was safer to try and move to a slightly more neutral territory. And so the territory I moved to is, I decided the best person to choose was Dick Schwartz. Now, many of you do know Dick, and when I was on the board of directors and wandering the halls of 445 Hose Lane several times a month for many days, and did this over quite a few years, that Dick was always there talking about the team, and the team. And we had cups made that had the team on it and this sort of thing, and I still have one of these cups. And I really started to wonder about Dick, because I felt like maybe like one of the former US presidents, he had played too much contact football without a helmet, and he was just being bothered somewhat. But then a little while ago, so I never really cottoned on to what he was trying to tell me, or maybe the other people didn't cotton on to it either. And Lou, after about 6 months ago, or about a year ago maybe, I was reading a Canadian business magazine of all things. And in it, there was an article about Margot Northey, who was the former dean of the School of Business at Queen's University. And in it, she said the following. She said that the difference between a team and a committee is that a team consists of a group of diverse people with a common goal, whereas a committee is generally comprised of a group of representatives whose duty is to make their voice heard. And I've been on a lot of committees and heard a lot of voices. And the important point was that in a number of those committees, we managed to hive off a small team, and that's where the work got done. So Dick, I now understand what you're trying to say. I'm sorry, and I do believe you did wear the helmet. Now, the third and most important, of course, is Louise. She, for many years, has put up with all my foibles and all the troubles I've caused her. And one of the ones, major ones, in fact, was what I believe is my bout, or severe and long bout, with severe acute voyageur syndrome. This is an ailment, a disease endemic among the IEEE volunteer community. And it's not only severe, it's chronic. So it's a rather interesting problem here. And among the various traumas caused by this disease, there was, for example, the memorable call from the emergency room in the Bellevue Hospital in New York, telling them that I'd just been delivered there by ambulance. But even worse one for Louise was the following. When she started coming to IEEE meetings and going to the breakfast and so on, she found there was no peanut butter there. And that to her was a big problem. But we've managed to cope with both. I stay out of hospitals, and she brings her own peanut butter to IEEE meetings. And so she's well looked after. And so behind every sort of successful volunteer, there's an indulgent wife or spouse, and I'm luckier than most. Thank you, Louis. And so finally, so that's the three talk about. And so since I'm part of the warm-up act for the stars to come here, I thought it might be appropriate to close with a quotation from Jack Benny, who, under a rather similar circumstances, being presented with an award, said something which applies equally well to me. And he said the following: "I don't deserve this award, but I have arthritis, and I don't deserve that either." So thank you.
The second service award is given in honor of Mr. Haraden Pratt, who served for more than 3 decades as a member of the IEEE Board of Directors. Established in 1971 and sponsored by the IEEE Foundation, the IEEE Haraden Pratt Award recognizes outstanding service to the IEEE.
The recipient of the 2003 IEEE Haraden Pratt Award is Dr. Charles W. Turner for his outstanding leadership in extending the transnational activities of the IEEE into Eastern and Central Europe.
Dr. Charles W. Turner has spent much of his career at King's College in London, where he served as chair of the Electrical Engineering Department for nearly 30 years, until his retirement in 2000. Dr. Turner is an IEEE Fellow and has served as IEEE Secretary and as the United Kingdom and Republic of Ireland Section Chair. He has been the IEEE Region 8 Secretary since 1999.
Charles Turner promoted the IEEE in Eastern Europe, where low salaries, limited resources, and language barriers placed local IEEE members at a distinct disadvantage. He set up offices in Budapest and Prague and developed a program to transfer hard copies of journals and microfiche from libraries of Western IEEE sections to those in the Russian Federation, Hungary, Bulgaria, Albania, Estonia, Latvia, and Lithuania. He also secured financial assistance for IEEE members to attend international conferences. Many thousands of talented electrical engineers were thirsty for details on state-of-the-art technologies. Charles Turner gave them plenty to drink. His dedication and tireless efforts on behalf of the IEEE have made him a role model for volunteerism in our organization. The recipient of the 2003 IEEE Haraden Pratt Award and the man they call Mr. Region 8, Dr. Charles W. Turner.
Thank you, Mike. Thank you, Art. Thank you to the awards committee. I'm quite overwhelmed by this award. When you receive an award for something that you basically enjoy and get great pleasure from, and when you also realize that there are many other volunteers who deserve at least as much as I have received from IEEE, you know you're really fortunate. My IEEE experience as a volunteer began something like 30 years ago through a simple phone call from someone in London who knew I was a member of IEEE and suggested I might become a student counselor. I really didn't know what I was getting into, but he was very persuasive. In fact, it was someone whom you know quite well, Bob Winton, who is an outstanding volunteer leader based in London. Bob is now over 90 and still does some work for IEEE. But he persuaded me to take a look at Eastern Europe at a time when that part of Europe was in a state of flux, and of course the Soviet Union was falling apart. And he understood how difficult it was for engineers, especially those working for the government in those countries, had in trying to pay the dues to be an IEEE member. And so he and I thought about various ideas that might enable these engineers to become members, and as Mike described, we embarked on some of these schemes. I have to say that not all of them worked. Engineers are used to that proposition. Some things work, some things don't work. But on the whole, we now see today, both in Eastern Europe and in the former Soviet Union, remarkable growth, much to their own credit. It's they who have really done the groundwork. And we see now, in the last few weeks even, 2 new sections, one in Siberia, one in St. Petersburg, that have been formed as a result of this growth and success. I don't want to take the credit for much of this because I'm only too well aware of many of my friends and colleagues in Region 8 who have worked hard and who have great and deep knowledge of these countries. But I do want to say that I'm very optimistic about the future for these countries in spite of their current difficulties, and I'm very proud to feel that IEEE has been an important agent in promoting this success. Like many other people, I owe a great deal to friends and colleagues in IEEE. I have been especially blessed throughout my career and throughout my volunteer time with IEEE with a very supportive family, and I want to thank my wife Shan, who is here tonight, especially for putting up with an awful lot, mostly a lot of absences, I suppose, a lot of hours spent working for IEEE, but I'm really grateful for that support, and it has helped me through some times when things got a bit difficult. It's easy for us in the West to take membership of an organization like IEEE for granted. But about a year ago, I received a letter from a volunteer from Eastern Europe who was retiring from his position as section chair. And he wrote to say that his experience as a volunteer for IEEE was absolutely the best thing that had ever happened to him. And when you get letters like that, it makes it all worthwhile. Thank you very much.
Ladies and gentlemen, it is now time to enjoy our dinner with colleagues, family members, and friends. We will return after a meal to continue the program. Before we break, let's give another round of applause for all our recipients and their accomplishments.
Ladies and gentlemen, once again, please welcome IEEE President Michael Adler and IEEE President-elect Arthur Winston.
Before beginning, we'd like to acknowledge and thank our musicians for their beautiful performance. I think they've already departed, but anyway, those who could hear it enjoyed it. So welcome back, everyone. I hope you enjoyed your dinner. Now let's return to our program. Sponsored by the Intel Foundation, the IEEE Robert N. Noyce Medal was established to recognize exceptional contributions to the microelectronics industry. It is named after Intel co-founder Robert Noyce, an innovator and leader who developed the technology that led to the microprocessor.
The recipient of the 2003 IEEE Robert N. Noyce Medal is Dr. Donald R. Scifres, chairman of SDL Ventures in San Jose, California. An IEEE fellow and the newest Eta Kappa Nu eminent member, Dr. Scifres is being recognized by the IEEE for pioneering contributions to the technology and business development of semiconductor lasers.
After many years developing pioneering semiconductor injection lasers at Xerox PARC, Dr. Donald R. Scifres founded Spectra Diode Laboratories Incorporated and turned it into one of the world's leading suppliers of fiber optic communications components and modules. When Spectra Diode Labs merged with JDS Uniphase in 2001, its valuation was $41 billion, the largest technology company merger in U.S. history.
Don Scifres can tell you that achieving a valuation of $41 billion is no stroll through the diodes. You have to come up with a lot of good, valuable innovations. Distributed feedback injection lasers, for example. At JDS, Don demonstrated the first of them, and they are now used in all long-haul fiber optic transmission systems, like those that enable high-speed internet connections. With research partner Dr. Robert Burnham, Don described and patented the first vertical cavity surface-emitting lasers. Today, they are the highest volume semiconductors used in communication. He and his colleagues also developed high-power diode lasers and diode-pumped solid-state lasers. Their work broke the ground in a field that now produces the small, efficient lasers used in medicine, metalworking, biology, and printing. A brilliant business leader and a creative scientist and engineer, this year's IEEE Robert N. Noyce Medal recipient, Dr. Donald R. Scifres. Take a picture of us.
Thank you. I'm really doubly honored tonight, and it's a thrill to get the Robert Noyce Award. As you all know, Robert Noyce was the pioneer in silicon integrated circuits, and a major business leader in that area. The team that I worked with at both Xerox and Spectra Diode Labs SDL did a lot of innovative work in optical integrated circuits over the years. And so we may have a situation where Robert Noyce begins to feel a little uncomfortable here as optical integrated circuits miniaturize the world of optics. And long term, the goal that we always had was to eventually miniaturize and improve on the silicon integrated circuit as well as optics. And so it's a challenge, I believe, to this audience and the members of this audience and the societies, the Electron Device Society members, the Leo Society members, to take that dream forward and eventually integrate optics and electronics all in one semiconductor wafer. So let's see what happens in the next 25 years, but there's a real challenge out there remaining. Thank you again, and it's a pleasure to receive this award. Thank you.
Our next award is the IEEE Dennis J. Picard Medal for Radar Technologies and Applications. Sponsored by the Raytheon Company, the award recognizes outstanding accomplishments in advancing the fields of radar technologies.
The recipient of the 2003 IEEE Dennis J. Picard Medal for Radar Technologies and Applications is Mr. William Skillman. Retired as consulting engineer for Westinghouse Electric Corporation, he receives the award for pioneering work in pulse Doppler radar design and its utilization for airborne early warning systems.
For nearly 40 years, William Skillman was a chief contributor to radar development at the Westinghouse Aerospace and Systems Division. His groundbreaking research on pulse Doppler radars laid the groundwork for the Airborne Warning and Control System, better known as AWACS. Mr. Skillman was also an early developer of radar programming for Texas Instruments TI-59 calculators and personal computers.
Bill Skillman was one of the principal architects of the AWACS system. This airborne early warning system was, and is, the most effective air surveillance tool available. It is used by the United Kingdom, the United States, NATO, Saudi Arabia, and Japan, among others. Continually sharing his knowledge, this IEEE fellow taught a radar course at the Westinghouse Evening School for 19 years and published seminal works on both AWACS and pulse Doppler radar. He is highly regarded, long-standing member of the IEEE Radar Systems Panel, where he has provided expert advice and contributions to IEEE Standard 686, Standard Radar Definitions. One of Bill's distinguished colleagues said, "He has earned the respect of his colleagues and the gratitude of all users of airborne radar." With our gratitude, we would like to present the 2003 IEEE Dennis J. Picard Medal for Radar Technologies and Applications to Mr. William Skillman.
Thank you very much. I'm very pleased and honored to receive this. I know two of the former recipients, Meryl Skolnick and Dave Barton, and it's really an honor to be considered in the same league with them. I thought you'd like to know a little bit about what is AWACS doing right now. Well, I can't tell you too much. It was in the Iraqi latest war, but it really goes back over 50 years ago when Westinghouse began looking into pulse Doppler. It was a little bit during the World War II, done by the Rad Labs, but nothing spectacular. So when I came to Westinghouse almost 50 years ago, we were just beginning this pulse Doppler research. It ended up in radars that were put into the F4, into the Beaumark radar seeker. We also developed the APQ-81, which is kind of the forerunner of an AWACS. Then in 1963, almost 40 years ago, the Air Force decided they needed something a little better for surveillance, and they came out with a requirement. So we've been actually working on AWACS starting 40 years ago. We ended up in a competition with about 7 different companies, and 3 of them were selected for a little fly-off called the Overland Radar Technology Program. Westinghouse, Hughes, and Raytheon, with the 3 in it. We flew in 1966, and unfortunately, Raytheon fell by the wayside. But I do want to thank them for this medal, giving it to one of the winners. Then, in 1972, we flew off against Hughes, the 2 survivors of this Overland Radar program. And I wanted to tell you a little secret of how we won. It wasn't technical prowess. You know, we'd like to think we're the best. But we really psyched them out because we had 2 separate airplanes, one for the Westinghouse, one for the Hughes. And the Hughes came over first. You've seen the big rotodome on top, 30 feet by 6 feet, and held up by 2 pretty strong struts. Well, Hughes' airplane came over with the rotodome on, and he's held up by these big struts. I was there when that happened, and I was there when Westinghouse plane came over, and they hadn't put the rotodome on. We just had these struts up. And one of the Hughes guys was heard to say, I guess we're going to lose because Westinghouse can do it with a pair of rabbit ears. As mentioned, there are a lot of countries that are flying AWACS today. There are a total of 70 AWACS in operation. 2 of them were lost in operation. 33 of them are used by the U.S. Air Force. Another 33 are used by 4 of the countries, NATO and UK and France and Saudi Arabia. And Japan has 4 of the more recent models that are in a 767 instead of the original 707. During the Gulf War I, AWACS flew 845 sorties, taking care of the airborne traffic over the Gulf. Somewhere around there, Drew Middleton, who was a military analyst for the New York Times, was quoted as saying, they used to send in the Marines, now they send AWACS. After 9/11, you probably heard that AWACS was patrolling the skies over New York City and Washington, D.C. Interestingly, at that time, since they were pulled off of their normal duties, NATO supplied an average of 5 airplanes to fly over this country to replace the ones that were on patrol over New York. I wanted to thank several people. One, Jim Fritsch, who was the one that sponsored me for this, he's here today. Bob Cowdery was the program manager for many years during the brass board, and he was in the process of moving, so he couldn't make it today. And I certainly want to thank my family, who's put up with a lot of absences of mind and body during this time. Ann, who's my bride of almost 55 years now, and my 3 children. Karen is over here with her husband, and I want to thank them also for presenting me with 2 wonderful grandchildren. So thanks again for the medal.
The IEEE Jack S. Kilby Signal Processing Medal is named in honor of one innovator whose work was a monumental precursor to the development of the signal processor and digital signal processing. Sponsored by Texas Instruments Incorporated, the award recognizes outstanding achievements in signal processing.
The 2003 IEEE Jack S. Kilby Signal Processing Medal is awarded to Professor Hans W. Schuessler, Professor Emeritus at the University Erlangen-Nuremberg in Germany. He receives the award for his leadership in the development of the field of digital signal processing, especially the theory, design, and implementation of analog and digital filters.
IEEE Fellow Professor Hans W. Schuessler was one of the first researchers in the world to recognize the potential of digital signal processing. His work was among the earliest to simulate digital filters on a computer. He was at the forefront of mapping optimal analog filter design methods to the digital domain, and over the last 30 years, he and his students have designed numerous digital filters for data communication.
Professor Schuessler was among the first to link signal processing and computing. Working in relative isolation with his students in Germany, he realized early that the basic elements of the computer, the integrator and the potentiometer, could be replaced by the delay element in a digital filter and multiplier, respectively. Nearly all of the basic structures now used in digital filters were simulated by this pioneer in the 1950s. His work on finite impulse response filter design set in motion virtually all of the optimal design methods in use today. And problems of practical digital filter implementation didn't stand a chance against his quantumization effects solutions. Professor Schuessler's text, Digital Signal Processing, was the second to be published in the field and the first in Europe. This publication, as well as other books on introductory systems theory communication systems, digital systems, and signal processing, defined digital signal processing in Germany and had a significant impact in the United States. Ladies and gentlemen, the 2003 IEEE Jack S. Kilby Signal Processing Medal recipient, Professor Hans W. Schuessler.
Thank you very much for the prize, for these very nice words. The whole thing was really a big surprise for me. I didn't expect it. I didn't even believe that it will come. It might come. Anyway, one other point in it is that the old work, rather old work, on analog filters was mentioned as well. This is more or less 40 years old. Well, I want to say a little bit about the digital part. In fact, we started with the design of digital filters. And if we talked about that, especially in Germany, quite a few people told us that will never work. Well, what can we do against that? We built a digital filter. And by doing so, we are running, as everybody else, in practical problems with the word length effects. And that means we have to do something new, and we have to find other solutions. And in fact, that's still a problem. We are still working on this point. But I should like to mention another point going along with the digital signal processing problem. We had very good relations to American colleagues. And the whole thing started with my stay in the United States at different occasions, a total of 2 years or so. I stayed at Cornell University in Ithaca. I was at the MIT. I was at the Rice University, exchanging ideas and changing results and working together with colleagues. But in my opinion, more important was that American colleagues came to Erlangen, working with us there, working with my students, educating them. And I mention some names. I mentioned Sidney Burris, who spent a total of 2 years, distributed over 20 years or so. I mentioned Jim McClellan, here today as well. I mentioned others who came over. Names are always difficult. But anyway, this cooperation was very successful for us, for me especially, for my students. And I think it was of interest for our American guests as well. But the award is my award. And that's just a surprise. Thank you very much.
Thank you very much.
The IEEE John von Neumann Medal is sponsored by IBM Corporation and is named for the famous mathematician who helped set the standards for today's computer architecture. The award is presented for outstanding achievements in computer-related science and technology.
Tonight, we present the 2003 IEEE John von Neumann Medal to Alfred V. Aho, Chair of the Computer Science Department at Columbia University. He is honored for contributions to the foundations of computer science in the fields of algorithms and software tools.
At Bell Labs, Dr. Alfred Aho developed widely used algorithms for formal computer languages that form the foundation of modern compilers and string pattern matching tools. This IEEE Fellow also helped produce the U.S. National Research Council's report on information technology literacy, which influenced the government's views on and support of IT research and development.
Dr. Aho's colleagues say that his work is motivated by important real-world problems which he attacks with deep insights into relevant theory and packages into useful tools. One of his more remarkable tools bears his initials. He is the A in the AWK programming language. The W and K belong to Peter Weinberger and Brian Kernahan, respectively. AWK embodies Al's computer science philosophy. It is an elegant combination of theory with good engineering sense. Although originally intended to be a simplified relational database, it serves many other purposes, including data processing. Another of the many programming languages Al developed was YACC. It was the first tool made for non-specialists to build parsers for programming languages. It's still in widespread use today because, as one of his colleagues says, nothing works better. For his work in changing software tool design from an ad hoc art into a scientific approach, it gives me great pleasure to present the 2003 IEEE John von Neumann Medal to Dr. Alfred V. Aho. Congratulations. I'll hold this.
I'd like to thank the IEEE for this very great honor. When I first received notice of this award, I felt three emotions. First was great jubilation, and then the second was I shouldn't get an award for work that I really enjoy so much doing. And the third was, well, there are lots of other people who deserve this award just as much as I do, because of the wonderful colleagues that I had at Bell Labs when I did a lot of this work. I thought maybe the best way to exemplify some of the power that bringing theory to practice has had was in a course that I taught last fall at Columbia University in programming languages and translators. What I've discovered is that if you let students exercise their creativity in the educational process, they will far exceed your expectations. And in this course, there is a design requirement the requirement for the project in the course is very simple. It's just to design and implement an innovative little language. Back in the 70s and 80s, when some of the work that I did that's being honored by this award was being done, writing a compiler took dozens of people a year or two in order to be able to bring it to completion. Now here is a senior level course at Columbia University where the students have never looked inside a compiler, and they're being asked to design both a language and a compiler for it in a 3-month course. It sounds like a rather forbidding undertaking, but there were 19 teams of 3 students each designing languages. The languages that they designed ranged from simulating quantum computers to making squares dance in artistic patterns across the stream, to better techniques for solving sparse matrix operations. And all of these languages were implemented on time, on schedule, which is a remarkable achievement for software, as all of you involved with software know. And not only that, but the students had a blast doing this. I was greatly honored recently to discover that the students so enjoyed this course, they gave me the Great Teacher Award from Columbia for this particular course. So not only has this technology helped revolutionize the design of compilers and programming languages for the computer industry, but I'm even more gratified that it has and is revolutionizing the way we teach languages and computer science in academia. And again, I'd like to thank the IEEE and the IBM Corporation for the support of this extremely great honor. Thank you.
Thank you.
The IEEE Richard W. Hamming Medal, named for a pioneer in the field of information science, recognizes exceptional contributions to information sciences, systems, and technology. The award is sponsored by AT&T Labs.
This year, the IEEE Richard W. Hamming Medal boasts two recipients, Claude Barreau and Alain Glavieux. Both are professors at École Nationale Supérieure de Télécommunications in Brest, France. They are honored for the invention of turbocodes, which have revolutionized digital communications.
Professors Claude Barreau and Alain Glavieux came to l'École Nationale Supérieure des Télécommunications in Brest, France in the late 1970s. The organization was in its nascent stage, and the two men had a dramatic impact on making it the prestigious institution it is today.
Professor Barreau helped organize l'École Nationale's curriculum in physics and electronics and led the establishment of the Laboratory for Integrated Circuits. Professor Glavieux was instrumental in developing a digital communication program and laboratory, as well as a research group focused on high-performance communication systems.
Together, Professors Barreau and Glavieux removed the gap between what error correction theories promised and what the systems were able to actually provide. They did so by replacing complex, one-shot algorithms with simpler, high-performance iterative substitutes. These colleagues dubbed these newly created family of error correction codes turbo codes. The turbo principle processes data in such a way that no information is wasted in error-correcting process. Because Claude and Alain challenged the conventional wisdom of skeptical experts, turbo codes have revolutionized digital communications. They play an essential role in third-generation mobile telephony and wideband code division multiple access systems. Ladies and gentlemen, please welcome Professors Claude Barreau and Alain Glavieux, the recipients of the 2003 IEEE Richard W. Hamming Medal. And here's yours. Thank you. Let's
Yes, for several reasons, it's a great pleasure for Alain and myself to be with you tonight. First of all, of course, we appreciate being awarded the Richard W. Hamming Medal, which is the most, or one of the most prestigious medals or distinctions in our discipline. We gratefully thank the Hamming Committee for having judged ourselves worthy of it. Second, it was just 10 years ago that we made our first public presentation about this new technology, turbocodes. It was in Geneva during ICC 93. So it is a highly relevant scientific birthday today. Furthermore, one of the reviewers of this first paper on turbocode is present today, and he will be awarded in a moment, and we thank Professor Hagenauer for his support. We have also friendly thoughts for some researchers whose early works were strongly related to turbocodes. In the USA, I think of Michael Tanner, Bob Gallagher, and in Europe, besides Joachim, I think of Professor Gérard Bataille in France. Finally, it's a great honor to be among so many distinguished representatives for IEEE, which is a warm-hearted and highly active community. If IEEE had not existed, we would have had to invent it promptly tonight. Thank you very much.
The IEEE Medal for Engineering Excellence was established in 1986 to honor exceptional achievement in application engineering in the technical disciplines of the IEEE for the benefit of the public and the engineering profession. The medal is funded by Siemens AG of Munich, Germany.
The 2003 IEEE Medal for Engineering Excellence recipient is Mr. Ralph S. Gens, engineering consultant to the Bonneville Power Administration. He receives the award for leadership in the advancement of high-voltage AC and DC transmission.
Under Ralph S. Gens' guidance as Systems Engineering Chief, Manager of Planning and Research, and Chief Engineer, Bonneville Power Administration in Portland, Oregon became a place of exceptional achievement in AC and DC high-voltage power transmission. During his more than 30 years with Bonneville, this IEEE Life Fellow led the development of one of the world's largest 500 kilovolt AC transmission networks and many other groundbreaking advances in power transmission.
When you turn on a lamp in your living room, you probably don't ponder the source of the electricity or the route it takes to the bulb. Well, Ralph Gens does. His vision of a high-voltage power transmission network became the record-breaking 846-mile-long, 500-kilowatt DC Pacific intertie, the link between the Pacific Northwest and the Southwest power grids. Ralph was also instrumental in the planning and implementation of the Northwest 500-kilowatt AC power transmission network. This encompassed many hydroelectric power stations located in Washington State, as well as the Hanford Nuclear Power Station. It is one of the largest AC transmission networks in the world. Ralph is known for fostering a culture of technical excellence. A proponent of knowledge sharing, he helped establish the Electric Power Research Institute and the premier U.S. Research Center for High Voltage DC Transmission Line Design, the Dallas, Oregon HVDC Test Center. Ladies and gentlemen, please welcome the recipient of the 2003 IEEE Medal for Engineering Excellence, Mr. Ralph Gens. Congratulations.
President Adler and Winston, fellow honorees, ladies and gentlemen. It has been said that all historic speeches are short. It doesn't follow that all short speeches are historic. However, I try to be short. First of all, my thanks to the many engineers at Bonneville that has made this award possible for me. As I said before, it is teamwork that makes us achieve great results. I also should, of course, acknowledge help of my family who put up with my many absences. The other day, I read a little excerpt that was trying to define leadership, and it is said, and I better read it carefully, leadership is about taking people on paths where they would not go by themselves. And I think most of us have been in a position to point the way to take the proper path. I would like to mention in this regard that when the DC technology was proposed in the 60s, there were a lot of naysayers. There were utilities saying nobody would ever connect to a system like that. There were statements made that we were building a 1,400-kilometer clothesline span. However, history, and as a matter of fact, there were gentlemen that was saying that he will delay his retirement until the DC line was operational. I guess he didn't want to retire. But history has proved somewhat different, that the line was placed in service in the early 70s, rated 1,440 megawatts at plus or minus 400 kV. Within 10 years, it was upgraded to plus or minus 500 kV. The transmission capacity now is 2,700 megawatts. twice the original design, still carried on the transmission towers with only 2 wires, the beautiful transmission towers that scattered our landscape. I'd like to mention that after 30 years in service now, the mercury arc valves, which were the pioneers stage at that time, are being replaced by solid-state devices. And it'll be a conjecture on all our part whether what the future will be 30 years from now in terms of that particular technology. I'd like to mention also that during that time that we were putting the DC tie together, there were no textbooks. We met once a week to study what was available until a textbook finally was published by N.G. Hingorani, and who happens to be in the audience today, a great help at that time. I'd like to share with you a couple of personal experiences in my career. The first one was when I was just coming to work, and my supervisor says to me, "You're not an engineer until you share your professional experience with your peers. You must join a professional society. You must participate in their technical activities." And I think that was the AIEE at that time. And I believe these are still the motives for the IEEE to exist. The other one was a chief engineer who had the habit of going around the organization and talking to young people, and to try to find out where's the activity, because it is in the younger segments of our organization. And he came to me one time and he looked me in the eye and he said, "Ralph," he says, "I want you to be right one more time than you're wrong." I kind of looked at him, and then he added, "Preferably the last time." Thank you again to the IEEE and to Siemens for this award that I treasure very much.
The IEEE Simon Ramo Medal was established in 1982 to recognize the distinguished career of its namesake. Sponsored by the TRW Foundation, it is awarded for exceptional achievement in systems engineering and systems science.
Tonight, we present the 2003 IEEE Simon Ramo Medal to the late David Heebner for leadership in introducing the towed line array sonar systems for long-range detection of submarines.
At Hughes Aircraft Company in the 1950s and 60s, David Heebner developed systems for acoustic signal processing that enabled submarines and other vessels to detect enemy submarines from great distances. Later, at the U.S. Office of the Secretary of Defense, he served as Assistant Director of Sea Warfare Programs and Deputy Director of Defense Research and Engineering. He also was Executive Vice President and Vice Chairman of the Board at Science Applications International Corporation in McLean, Virginia.
David Heebner's towed line array sonar systems made a huge splash when first deployed. But the key to their success, ironically enough, was the splash was imperceptible. His systems allowed U.S. submarines to find and classify adversaries without being detected. The systems transmitted multiplex hydrophone signals to a processor over a single wire. This resulted in very long towed arrays that produced safe areas where a sub could travel with impunity, even at high speeds when it was blinded by increased flow noise. One of David's distinguished colleagues said that, outside of nuclear propulsion and submarine-launched strategic missiles, no single system development had such profound impact on the military effectiveness of the U.S. naval forces during the Cold War. David passed away in January. So tonight we honor not only his work, but his life. David's family was not able to join us this evening, so I am pleased to accept the award on David's behalf.
The IEEE Alexander Graham Bell Medal was established in 1976 to honor exceptional contributions to the advancement of communications, sciences, and engineering. It is sponsored by Lucent Technologies.
The recipient of the 2003 IEEE Alexander Graham Bell Medal is Professor Joachim Hagenauer, Professor of Communications Engineering at the Munich Institute of Technology. He receives the award for contributions to soft decoding and its application to iterative decoding algorithms.
From 1977 to 1993, Professor Joachim Hagenauer transformed the Institute of Communications Technology at the German Aerospace Research Center into one of the world's leading centers of communication and research. Since 1993, he has chaired the Communications Technology Department at the University of Technology in Munich. He is an IEEE Fellow and a long-standing member of the Bavarian Academy of Science.
Before Professor Hagenauer began his research, decoding was based on hard binary decisions. It was about determining code words or sequences with the smallest probability of error received from noisy signals. He determined that a decoder could improve the signal-to-noise ratio based on code constraints. Soft or unquantized values should be considered by a digital receiver until the final decision is made. His grasp and application of soft-in, soft-out decoding paved the way for the turbo coding developments we honored earlier this evening. Professor Hagenauer brought coding into the way we communicate. Soft-in, soft-out coding has revolutionized digital communications over the last 10 years. GSM, third-generation mobile transmission systems, and satellite transmissions all rely on the application of his ideas. Ladies and gentlemen, it is a great pleasure to welcome the 2003 recipient of the IEEE Alexander Graham Bell Medal, Professor Joachim Hagenauer. Congratulations.
Well, prior to this festive occasion, my wife and I went camping in beautiful Maine and Massachusetts. Our trip terminated in Salem, Massachusetts. You remember that's where also witchcraft was done. By chance in Salem, we suddenly stood in front of a building with a memorial inscription saying, on February 22nd, 1877, Alexander Graham Bell presented here the first long-distance telephone conversation. I guess this demo must have appeared to the folks in Salem as a kind of new witchcraft at the time. And still, I personally feel also bewitched when I travel here in beautiful Tennessee on a highway and talk via my mobile phone to my children who at the same time travel on a rural road in Tuscany, Italy. And it works. My work is related to this witchcraft called mobile telephony. Of course, we all do it digitally those days and transmit bits instead of analog waveforms. My contribution, however, goes slightly back to analog. Bits are transmitted not just as zeros and ones, but together with their probabilities. Soft bits, we call it. That's how we do it now, is a soft way. This allows the design of mobile receivers with much better performance, resulting finally in error-free transmission. Our slogan is, soft is better than hard. I would like to thank not only the committee for this prestigious award, but also my friends at the Communications and Information Theory Society. Especially at the Information Theory Society, we are still inspired by the great work of Claude Elwood Shannon. But I also would like to pay tribute to those scientists from whom I learned a lot: Professors Jim Massey, Andrew Viterbi, Dick Blayhood, and Dave Forney. Thank you very much for this award. Thank you.
This next medal recognizes a career of outstanding contributions to education in the fields of interest of the IEEE. Sponsored by the IEEE Life Members Committee, it was named in honor of James H. Mulligan, Jr., a highly esteemed educator and the 1971 president of the IEEE.
The 2003 IEEE James H. Mulligan, Jr. Education Medal is presented to Professor Yasuharu Suematsu, Director General of the National Institute of Informatics in Tokyo, Japan. He receives the award for outstanding leadership in graduate and undergraduate education as mentor, professor, and president, and for pioneering contributions to research and education in optical communication devices.
Professor Yasuharu Suematsu has inspired numerous students worldwide through his more than 260 journal papers and 16 books. Two of his texts, An Introduction to Optical Fiber Communications and Electricity and Magnetism, are valued references around the world. For more than 30 years, he served as researcher, professor, dean, and president, and mentored more than 60 PhD candidates at the Tokyo Institute of Technology.
In all aspects of his teaching and research, Professor Suematsu has stressed the importance of both theoretical innovation and practical applications. Often in partnership with his students, he has played a major role in optical communications in Japan and around the world. He has made fundamental contributions to the dynamics of semiconductor lasers, high-capacity single-mode lasers, and long-wavelength optical fiber transmissions, and to devices such as optical modulators based on quantum size effects. More importantly, his impact in the field of optical communication can be seen in the career successes of his students, most of whom are leading highly distinguished careers in academia and industry. Ladies and gentlemen, the recipient of the 2003 IEEE James H. Mulligan, Jr. Education Medal, Professor Yasuharu Suematsu.
It is my great honor to be awarded the 2003 IEEE James H. Mulligan Jr. Education Medal. I wish to express my sincere gratitude to the President of IEEE, the board members, and the committee members, and those who supported me. I am deeply grateful to be added to the list with distinguished previous recipients, started from the Professor F.E. Thurman. I am especially happy to be honored in my second mother country, as I spent a year at Columbus, Ohio, 35 years ago. And since then, I have learned greatly from this ever-learning country, and a lot of friends here. When I look back on my 40 years research period on turning dream of optical communications into reality from its dawn of interest, with my students and many colleagues of all over the world, thousands of emotions cloud on me. It was especially excited when we suggested to realize a single-mode long-wavelength semiconductor laser at the wavelengths of 1.5 micron for high-capacity optical fiber communications. The reason why I am here is that I was good for educating students, but in reality, I myself was educated through discussions in depth with them. In this occasion, I wish to express many thanks to my former doctoral student. Among them, Kenichi Iga is included, and actually he is the IEEE Daniel Nobel Prize recipient of this year. And I wish also express to my supervisor, Professor Morita. He guided me the importance of the research as well as education. Thank you very much for your attention.
Established in 1952, the IEEE Founders Medal honors the three leaders whose vision and service created the IEEE: Alfred N. Goldsmith, John V. L. Hogan, and Robert Marriott. This prestigious honor recognizes outstanding contributions in the leadership, planning, and administration of affairs of great value to the electrical and electronics engineering profession. It is sponsored by the IEEE Foundation.
The recipient of the 2003 IEEE Founders Medal is Mr. Raymond S. Stata, co-founder, former CEO, and present chairman of the Board of Analog Devices Incorporated. He receives the medal tonight for leadership in the electronics industry through innovative technological development and visionary contributions in entrepreneurship, management, and education.
In addition to leading over 35 years of business innovations at Analog Devices, Raymond Stata co-founded the Massachusetts High Technology Council, the Center for Quality Management, and the Engineering in Massachusetts Collaborative. Since 1987, he has been called upon for his organizational expertise by the U.S. Executive Committee on the Council of Competitiveness.
When Ray Stata co-founded Analog Devices in 1965, he believed that high-performance optical operational amplifiers would be the future of signal processing. He was right. Today, operational amplifiers, data converters, and digital signal processors are the essential signal processing technologies. Ray's vision and ability to navigate change have helped Analog Devices grow revenues 30% annually over the last 35 years. He has transformed the company from a discrete components producer in the 1960s to a market-leading provider of high-performance analog, mixed signal, and digital signal processing integrated circuits today. Ray created the Massachusetts High Technology Council to promote his conviction that engineering education and university funding are the responsibilities of government and industry. Under his leadership, the Council established the 2% Solution contribution program to encourage corporations to donate a portion of their research and development budgets to education. The Council also spawned numerous outgrowths that nurture interest in science and math among pre-college students. In the words of one of his peers, Ray is a successful high-technology business leader who is first and foremost an electrical engineer who believes his profession has much to offer to advance the state of humankind. Ladies and gentlemen, the 2003 recipient of the IEEE Founders Medal, Mr. Raymond S. Stata. Congratulations.
Well, thank you very much. Over the 50 years since I first touched the engineering professional world, the members of the IEEE have led a dramatic transformation in the way that we live and we work and we play, and in the quality of life that we enjoy. And now, thanks to the internet and thanks to the continuing rapid pace of progress in information technology, we're on the threshold of touching the lives of billions of people in developing countries around the world who, so far, have not benefited from the advances in science and technology.
And for me, this is one of the most promising climaxes of what we've been about for these past 50 years. I think everyone in our profession should feel privileged, as I do, to have participated in these magical years, and that we should all feel very proud of what we have accomplished together collectively. Therefore, it's with a very special and great pride that I feel honored to be singled out for distinction in the work that I've done over my career, particularly by such a prestigious organization as this, and to be listed amongst the many great leaders in our industry, both past and present. Now, my personal success is very tightly intertwined with the success of my company, Analog Devices, and with the thousands of employees and engineers who, over the last 38 years, have pushed the frontiers of signal processing technology in both the analog and the digital domain. And I must say, as we look forward, we're still enthusiastic about what is yet to be achieved. And at the same time, my life has been very much integrally and intimately intertwined with the partner of my life and my wife, Maria, who's with me here this evening. And so both my wife, Maria, and the employees of Analog Devices very much share in the recognition that I'm receiving here this evening. You know, in looking ahead, I believe one of the great opportunities for IEEE as an organization and for its individual members is to focus our energies on improving the disastrous state of education in science, physical sciences in particular, and math, in our middle schools especially, but throughout our K through 12 public school systems, with the goal of encouraging more of our young people to vigorously and enthusiastically pursue engineering careers. I know that IEEE already is a supporter of many programs in this domain. Just to mention one, the ReSeed program that was financed by the National Science Foundation encourages retired engineers to enter into the classroom with teachers who may not be as qualified as they to speak in matters of science and technology, and to use the materials that's been developed through the National Science Foundation to make, for the middle schools, technology and science truly exciting for our young people, and thus attract them into our profession. And this is not such a bad way for us in our retirement years to find rewards and productivity and fun in things that we can do that will help our society. Thank you very much.
The Medal of Honor is the IEEE's highest award. It is sponsored by the IEEE Foundation, and it is presented for an exceptional contribution or an extraordinary career in the fields of interest of IEEE. In the past 86 years, 83 individuals have received this award.
In 2003, Dr. Nick Holonyak, Jr., Professor of Electrical and Computer Engineering at the University of Illinois at Urbana-Champaign, is the recipient of the IEEE Medal of Honor. This IEEE Life Fellow receives the award for a career of pioneering contributions to semiconductors, including the growth of semiconductor alloys and heterojunctions, and to the visible light-emitting diodes and injection lasers.
Dr. Nick Holonyak, Jr. began his career at Bell Labs in 1954 and served in the U.S. Army Signal Corps from 1955 to 1957. After 5 years as a physicist and manager at General Electric, he accepted a professorship at his alma mater, the University of Illinois. Today, he is the John Bardeen Chair Professor of Electrical and Computer Engineering at the university.
Nick Holonyak, Jr. is no ordinary man. His work is all around us. If you have a dimmer switch in your dining room, it probably has one of his silicon-controlled rectifiers in it. Car taillights, stoplights, and the lighting industry at large are the direct beneficiaries of his invention, the first visible light-emitting diode, or LED. So are digital watches and calculators and the giant video displays at sports stadiums. Approximately 60 billion LEDs were sold in 2001, 12 for every person on the planet. Today, LEDs are a $2 billion a year industry. The vast amounts of information that travel across the internet would not be possible without Nick Holonyak quantum well lasers. Virtually all types of semiconductor lasers use them. This practical laser for fiber optic communication also is common in hospital operating rooms for diagnosis, surgery, and ophthalmology. DVD players work today because of the impurity-induced layer disordering technology Nick and his students developed. This discovery gave lasers the reliability and durability needed to make them the backbone of the newest optical storage equipment. Nick had the great fortune of being the first graduate student and longtime friend of two-time Nobel laureate John Bardeen. From his work, we can see that Nick learned from his mentor how to point the way, first in silicon and then in light emitters and lasers and compound semiconductors. Nick, earlier this month in Russia, you received one of the first 3 International Global Energy Prize awards. In the past, you've also been honored by the President of the United States and the Emperor of Japan. Tonight, it is with great pride that the members of your profession present you with IEEE's highest award, the IEEE Medal of Honor. Before hearing from Nick, we should look a little more closely